Hi everyone, it's Coach Fred, and so we've been working on translating the sine and cosine graph. At this point, we've learned about what this A value means. It tells us about the amplitude. B tells us about the period, and D tells us how the graph's been shifted up or down. And they mean the same thing whether it's sine or cosine. And you're going to learn other graphs that it does means the same thing. But today we're going to look at what C does, okay? So since we've already moved, we've basically vertically stretched it, we've changed the period, so we've either made it happen really fast or slow down, and we've moved it up and down. We now need to look at moving it left or right, or moving it horizontally, okay? So when we move a graph horizontally, we call it a phase shift, okay? And I just want you to think about the phase shift being how far it's moved left or right from its usual position. How far left or right. So if I took a graph, let's just say, and I gave you like a regular graph like sine, and it looks like this. If I move it, this is its usual position. It starts at, like, we call it starting, at 0, 0. I could move that usual starting point to like right here. So now it looks like that. That's a phase shift, so moving it left or right. And we've done this before with all of our other graphs because it's consistent with the translations we've done with other functions. All right, let's look at it. So here we have y equals sine x minus pi. Now, there's many ways to do this. I'm showing you one way to do it, but I want you always to have it in the form y equals a sine b x minus c plus d. So if there were a value inside the parentheses in front of x, you'd want to factor that out, okay? All right, so let's kind of break down what we know. Well, we know the period is not changing, so we know our period is 2 pi. Why? Because the b value is 1. We know our amplitude is also 1, so that hasn't changed. All right, but our phase shift is on the inside of the function. Think about what value you'd put in for x to make it 0 because you're moving it left or right along the 0. So this would be right pi. So just like the quadratic, just like the square root, it's really the opposite direction of what you think. It's counterintuitive. So the graph's going to move right pi units. So that means a usual point, all the usual points are going to get shifted to the right pi units. All right, so just quickly, I have a little graph up here started for sine. We know that sine normally starts at the midline at 0. Remember, that's what we call our midline. And it goes up to 1 at pi over 2, back to the midline at pi, down to -1 at 3 pi over 2, and back at 2 pi. Okay, so those are the usual points. Now, that's only one period of the graph. Remember that I can continue and keep going with the graph forever and ever. Okay. But that means this point here is going to get shifted to the right pi units. Okay, now let's think about this because remember, we still want our nice 4 symmetrical units, okay? Okay, so that's why we always want to get our quarter period. So our quarter period is pi over 2. Okay. So I want you to think about, let's always look at that 0 point, that starting point for sine. That's what I'm going to shift. So I'm going to be moving that over to pi. And then from pi, I'm going to be going pi over 2 units. So if you want to get your period and your phase shift in the same denominator, then this would actually be 2 pi over 2. So then this would be 3 pi over 2, 4 pi over 2, which is 2 pi, 5 pi over 2, and then I'm going to go a little bit, 6 pi over 2, which is 3 pi. Okay, now if I went in the other direction, I'd be going backwards, so I'd be going back pi over 2. So from pi, I'd be at pi over 2, back to 0, negative pi over 2, and then negative pi. And I could keep going, -3 pi over 2, -2 pi. Okay, so now I'm ready to start my graph. So I'm going to shift over to pi. Actually, let me clean that up. I'm going to start there at 0 at my midline. I'm going to go up to 1. I'm going to go back down to 2 pi. I'm going to go down to -1 and then back up at 3 pi. So there's one period of the graph from pi to 3 pi. My period is still 2 pi. So from pi to 3 pi, I've gone 2 pi. Started it at pi. Now if I were going to go the opposite direction, I'd be going down to -1, up at 0, up to 1, and so on. Back, back. So let's do this. Let's see if I can get this on my graph pretty. And there's my graph. Now, it actually looks really interesting. It kind of looks like if I had just flipped this graph over, this is the graph I would get. And that can be a translation to this graph. So, all right, let's put this all together. Here we go. Y equals, again, I use sine. Sine 2x minus pi. Okay, so this is different, right? Because we have that 2 in front of it. So the first thing I want to do, no matter what, is factor out the 2. And again, you don't have to do it like this. That would give me pi over 2. Okay, so what's my period? Well, period is 2 pi over b. My b is 2. Ooh, so my period is pi. I want to get my quarter periods, which would be pi over 4. My amplitude, there's a 1 in front, so my amplitude is 1, so that's half the distance between the max and the min is 1. And my phase shift, okay, it's a minus, so I'd be going to the right, pi over 2. Okay, so remember, that's basically how far we're moving from our original positions. Okay, so I'm going to start at pi over 2. Okay, but remember, we really want our quarter period and our phase shift to have the same denominator and make it easy for ourselves. So to make that would be 2 pi over 4. Okay, so 2 pi over 4 is pi over 2. Going another pi over 4 would be 3 pi over 4. 4 pi over 4 would be pi. 5 pi over 4. 6 pi over 4 would be 3 pi over 2. And I'll do one more, 7 pi over 4. Okay, if I went backwards the other direction, I'd be pi over 4, 0, negative pi over 4, and I'm going to just do negative pi over 2. Okay, my amplitude's still 1, so I'm up at 1 and down at -1. I think I left the numbers off the last one. Okay, so now you just have to think it's the sine. So sine starts at the midline. I need it to start at pi over 2. So I'm here, then I'm up to 1, down to pi, down to -1, back to the midline, back up to 7 pi, down to pi over 4. My symmetry is a little off here, guys, sorry. At 0, back up to 1, and back here. And I could keep going and going, right? I think it's important for you to pay attention to what the directions say. Oops, it's going to look really off there, sorry. You know, because usually you're going to see teachers say, you know, provide 2 periods of the graph. So let's see if we've got 2 periods. So it starts here and goes, that's 1 full period here to here. And yeah, I got another full period. I can see the graph has occurred twice, at least in my graph, and a little bit more. All right, so that's how we shift left or right, the sine or the cosine graph. Just remember that the cosine graph doesn't start at 0. If we're thinking about the cosine graph, it starts up here at 1 and goes down and back up. All right, hopefully that was a helpful video. Have a great day.